Okay, for what we have in the next item, okay, we have the matrix of a linear transformation. And let's say we have letting t be a transformation as we go from Rn to Rm, whereupon we have t to be a linear transformation. And from this, there must exist a unique matrix A such that the transformation of x is equal to A times x for all x in Rn. And again, A is going to be the m by n matrix whose jth column is the vector where we have the transformation of E of j, where E of j is going to be the jth column of the identity matrix in Rn. And now let's say that in looking for, let's say a unique matrix A, and let's say that we have, as an example, say we have a two-dimensional identity matrix. Okay, we have I of 2 is equal to 1, 0, 0, 1, and we'll have just utilizing the variable E, okay, and we have from the identity matrix, we have two columns. First column we'll designate as E of 1. Second column, which consists of 0, 1, we'll have designated as E2. And we have supposed that the transformation is going to be linear as we go from R2 to R3, such that, okay, the transformation of the first column is going to lead to 2, negative 4, 6, and that of the second column will lead to 2, negative 8, 0. And in the process, okay, if we find a formula for the image of an arbitrary x in R2, so again we have x, okay, and if we put in as a 2 by 1 matrix, have x1, x2, and again we have our identity matrix, I of 2 times x, and just specifying and just breaking it up in terms of a vector equation. So you have x of 1 times the first column plus x of 2 times the second column. And again, we have E of 1 and E of 2 respectively representing the first and second column. So this comes out to x1 E1 plus x2 times E2. And since t is a linear transformation, okay, we have t of x, and this will be equal to x of 1 times the transformation of E of 1 plus x of 2 times the transformation of E of 2. So you have x of 1 times, again, you have for the respective transformations, you have times 2, negative 4, 6 plus x of 2 times 2, negative 8, 0. And then we have in this particular case, all right, for the formula, this will come out to the matrix where we have the top row at 2x1 plus 2 times x of 2. Middle row we have at negative 4 times x of 1 minus 8 times x of 2. And for the last row, we have 6 times x of 1 plus 0. And we have, again, so we have for the transformation of x, you have, again, you have the matrix going from the transformation of the first column to the transformation of the second and last column. And we have times x, where we have in column formation, you have in matrix equation form, you have x of 1, x of 2, and again, this comes out to a times x. So we have for our unique matrix, okay, we have a to be equal to, again, the matrix what we have resulting from the transformations and the respective columns. Okay, we come out to where A is equal to where we have in the 2 by 3 matrix. Okay, we have going column by column, we have 2, negative 4, 6, and 2, negative 8, 0. Right. Now, let's say that just some examples. If we're looking for A, say we have finding A, the standard matrix of T, and we have given, okay, you have the transformation going from R2 to R3, and you have the transformation of E1 is equal to 147. That of E2 we have equal to negative 257. And we have for the matrix A, again, you're looking at what's going to be a 3 by 2 matrix, okay, and so we have just in the arrangement, okay, we have the first column we have from the transformation of E1, so we have 147. Second column we have that from E2, so we have negative 257, and that would be the resulting matrix. All right, and now we have, say, another case. All right, so we have going from R of 4 to R of 2. Okay, and we have with the respective transformations, that of the first column we have 2, 8. That of the second we have negative 1, 5. That of the third column we have negative 4, negative 7, and that of the fourth and last column we have 6, 8. And so we have for our distinct matrix, okay, this time this will be a 2 by 4 column, and just since the transformations of each column is given. Okay, we just have displaying in column formation. We have for the distinct matrix A, we have 2, 8, negative 1, 5, negative 4, negative 7, as well as 6, 8. All right, now this is just for items we have in the linear transformation, and we're going to make a bit of a segue to what we have with transformations and rotations.